On this wobbly Wednesday, as the announcement said, October 10th, 2018, somebody's birthday today, so we'll have to take out our bird legs later in the afternoon. But first, let's talk about Lesson 2.5, Module 2, Lesson 5. Today we're going to learn, once again, we're going to revisit our friend, the area model, okay? And we're going to learn more specifically how the area model is basically the same thing as the standard algorithm. Okay, remember when we used a place value chart for division and I showed you how it was basically the same thing as the standard algorithm? Today I'm going to show you how an area model is the same thing or it's related to the standard algorithm for multiplying numbers. Today we are going to learn how an area model is the standard algorithm. So go ahead and write down this problem, 5 times 21, in your notebook. The directions tell us to draw an area model and then to solve it using the standard algorithm. It says to use arrows to match the partial products from the area model to the partial products of the algorithm. Remind me again, what's a partial product? Is it the final answer? No. It's only a part of the final answer. A partial product is part of the product. That's why it's called the partial product. As we know, area models always start with what shape? Rectangle, because we need to find the area of a rectangle. I want you to notice that I put one of the factors on the side here, 5. And then why did I get 20 plus 1? What does that equal? What's 20 plus 1? 21. Why did I split this other factor into 20 plus 1? Okay, go ahead and draw your area model into your notebook. I want you to be precise and notice that I wrote the first factor, 5, on the side. And the second factor, 21, I split it up at the top. Now set up your standard algorithm. You'll notice my first factor is on the top, and then my second factor is underneath it. Okay? Because of what we're doing today with partial products, it matters what order you put the factors in. But because of the commutative property, does it really matter? Is it going to change the answer? No. But for our purposes today, I want you to always put the first factor on top of the standard algorithm and on the side of the area model, and then, does that make sense? And the second factor underneath it. Okay, now let's multiply. If I want to find the area of this part of the rectangle, I want to find just partial products, just this part. How do I find the area of that red part? I need to multiply the length times the width. So Martha, what's the length times the width? What are the two factors?
5 times 2 tens.
5 times 20 or 5 times 2 tens. I love the way you said that. Okay, we can do that in our head because we know that 5 times 2 is 10, so I'll write that down first. And then how many factors of 10 or how many extra zeros do I have?
1.
So I have to add that. So 5 times 10 is 100. Okay? Again, just like we did before with area model, we'll write the multiplication equation inside the box, and underneath we'll write the partial product in standard form. Next, I want to find the area of this part of the rectangle. Okay, what is the length again from here to here? 5. It's the same as from here to here. Do you agree? Okay, so to find that area, we'd have to do 5 times 1 equals. So once again, we'll write the multiplication equation inside, and then we'll write the standard form on the bottom. It's just 5. So which one's the right answer of the product? 100 or 5? They're both partial products. In order to find the area of the total rectangle, which is what I'm trying to do, to find 5 times 21, I have to add those together, don't I? So what's 100 plus 5? 105. Now, let's see what's happening when we do the standard algorithm. First, we have to do 1 times 5. Don't you think? What is 1 times 5? 5. Now I'm working in the tens place, so what do I have to do? I have to put a placeholder 0. What's 2 times 5? 10. Okay. If I add that up, do I still get 105? Let's draw arrows to show where the partial products match up. Here's 100. There's 100. Here's 5. There's 5. Here's my total product. There's my total product. Do you see how every part of the area model matches up with one part of the standard algorithm? Yeah. Very nice. This real-life story problem says a young snake measures 0.23 meters long, or 23 hundredths of a meter. Okay? During the course of its lifetime, he will grow to be 13 times his current length. What will be his length when he is full grown? Okay, so the snake starts out small, but it's going to grow 13 times as big. The question is asking us, and you should write down step 1, what will be the total length of the snake when he is full grown? That's step 1. Again, you don't need to copy the whole question. Just write down, we're trying to find the length of the full-grown snake. So you could write step 1, what is the length of the full-grown snake? We need to know that the snake starts out as a baby, measuring 0.23 meters long, or 23 hundredths of a meter. What else do we need to know? He's going to grow to be how many times his current length? 13 times. Okay, very good. So number 2 in your word on your notebook, you're writing down 23 hundredths meters long, and then 13 times his current length. What do we need to do? What math problem are we going to need to do to solve this? Are we going to need to add, subtract, multiply, or divide? Everyone? We need to multiply his current length, 23 hundredths of a meter, times 13. Do we know how to multiply decimals yet? Nah, we didn't learn that yet. So how can we get rid of this decimal point? How can we rename this so that there's no decimal point? I only want whole numbers. I only want whole numbers. I can rewrite this in unit form. I can say this is 23 hundredths. Go ahead and write it in your notebook too. Times 13. Then I can just think about 23 times 13. Well, let's use an area model to do 23 times 13. If I'm going to draw an area model, I know that my first factor goes here, 23, and then I want to put 13 on top, but how should I split it up into 2 parts that will make it a lot easier? Prisha? 10 and 3. Then I can find the area of each part. I can do 23 times 10. Is that easy for us to do in our heads? What does that equal?
230.
230, very nice. Then, oh, don't forget to write the partial product at the bottom. Then over here, I can do 23 times 3. Also easy for us to do in our head. What's 23 times 3? 69. Very good. So we'll write that partial product down here. And if I add up 230 plus 69, I'm going to write it in standard algorithm to add so I don't mess up the place values. I can see that the answer is 299. At this point, though, it's very easy to make a crucial, silly mistake, right? Is it 299 ones? No. We have to go back and remember it was 299 hundredths because our units were hundredths. Okay, so let's write it into standard form. 299 hundredths. I know I had the number 299, but I need the 9 to be in the what's place? The hundredths place. So go ahead and place your decimal point where it would make it 299 hundredths. Where does the decimal point need to go? Arnav?
Between the 200.
Very good. And now we have to look back at our problem and see what the units are. What is it? Meters. So my final answer is 2.99 meters long.